Hello students, today we are going to talk about coordinate geometry, which is chapter 12 of our textbook. And the first topic will be distance between 2 points. And let's say we have an xy coordinate plane. This is the x-axis and this is the y-axis. And this is line AB. And we have point A, the coordinates is x1, y1, and point B, the coordinates are x2, y2. And we call this small letter 1, small letter 2, the subscripts, SUB, SCRIPTS. Then obviously, in coordinate geometry, we have numbers at the points. We have numbers x, y coordinates at the vertex of the lines or the triangles. So it is actually the application of algebra on geometric objects. And now, let's say we are going to find the distance, the length of this line AB. How can we find the length of this line AB? And it is quite obvious that this ABC is a right-angled triangle. And if we can find the length of the horizontal side and the height of the triangle, then we can make use of the Pythagoras theorem to find the length of AB. And now can we find, let's say, BC first. How can we find BC? And obviously, y1 is the y coordinate of point A, and y2 is the y coordinate of point B. And we can think of the y coordinates as the height of the point above the x-axis. So the height of point A will be y1, the height of point B will be y2, above the x-axis. So the length of BC will be y2 minus y1. And for AC, we can imagine the x-coordinate of point A is x1. That is, point A is with a distance of x1 on the left-hand side of the y-axis. That is, from here to here, the distance is x1. And from here to here is x2. So therefore we have AC x2 minus x1. So finally, the length of AB will be make use of the Pythagoras theorem. Therefore we have AB equals to the square root of AC squared plus BC squared. And AC we have x2 minus x1. And for BC we have y2 minus y1. Therefore, this is our distance formula. The square of the difference of the x-coordinates between 2 points plus the square of the difference of the y-coordinates between 2 points. And finally, we take a square root on the outside. And therefore, if point A is 2, 3, and point B is 6, 8, then we can immediately apply the distance formula to find the length of AB. We first write the format in this way. And then we subtract the x coordinates. That is 6 minus 2. And then taking square. Plus the difference of the y coordinates, which is 8 minus 3. And therefore we can simplify the expression. And this is the square of 4, we have 16. And this is the square of 5, we have 25. And the final answer is the square root of 41 units. And finally, I want to make one more point on the location of point C. Can we write down the coordinates of point C? And you can see that the x-coordinate of point C will be 6, which should equal to the x-coordinate of point B because they are on the same vertical line. And the y-coordinate of point C will equal to the y-coordinate of point A because AC is on the same horizontal line. So this will be 3. And now we can go over example number 1. Calculate the length of AB in each of the following. Correct your answer to 2 decimal places. find the length of AB, we can simply apply the distance formula. For part A, AB, this represents the length of AB, which is, we find the difference of the x coordinates and the difference of the y coordinate and then take square. We add it up and then taking square root. So let's say point A is x1, y1, therefore we have 5, 7. And then for point B, we have x2, y2, 3 minus 6. This will be, or we can do it mentally. 7 minus the negative of 6 will be 7 plus 6. And this is the square of 2. And this is the square of 13. And by using our calculator, the answer is 13.15 unit. Again, for part B, we can apply the same formula. We first write the format of the distance formula first. And again, we can make A as x1, y1, minus 1, 3. And note that if we choose the point A as the point x1, y1, we remember we have to stick to that choice. And for B, we have minus 5. But we can do it mentally in this way, because minus 1 minus subtract negative 5, we have minus 1 plus 5, sorry. And 3 minus negative 2, we have plus 2 here. Since the coordinates of point B are all negative numbers, negative 5 and negative 2. So this will be the plus sign here. And again, we simplify the expression. This will be the square of 4, which is 16. The square of 5, it will be 25. And our answer is 6.40 unit. Okay, example 2. A, B, C are the 3 vertices, 頂點, 頂角 vertices of triangle ABC. Find the perimeter of triangle ABC. Correct to 2 decimal places. And now the first thing we need to do is probably we have to draw our own diagram, because in the recent trend of the public examinations, there are fewer and fewer diagrams given to the candidates, so we have to draw our own. So we have this x-axis, and this will be our y-axis. So point A is 1, negative 1, point B 5, negative 1. So these 2 points have the same y coordinates. That is, they should be on the same horizontal line. So we have point A will be maybe somewhere like this, 1, negative 1. And then point B, we have 5, negative 1. They should be on the same horizontal line. And for point C, it will be 5, 3. So it has the same x coordinate as point B. So point C will be directly above point B. The y coordinate is 3, so it will be above point B. So this will be a right angle. And it is obvious that triangle ABC is a right-angled triangle. So the problem requires us to find the perimeter of triangle ABC. So AB is quite easy because we simply subtract the x coordinates. And for BC, again, it is quite easy. We simply subtract the y coordinates. But what about AC? Again, we have to apply the distance formula. Therefore, we can write down AB is 5 minus 1, 4 units. And then BC, this is a vertical line. 3 minus negative 1, therefore we have 3 plus 1. Again, 4 units. And for AC, we apply the Pythagoras theorem or the distance formula. Actually, in this problem, we can simply apply the Pythagoras theorem, because this is 4, this is 4, we don't need to apply the distance formula. So this will be the root of 32. And then this is 5.66 units. And remember, don't forget the parameter. Therefore, parameter equals to 4 plus 4 plus 5.66, which is 16.66 units. And actually, this triangle is more than just a right angle triangle, because AB and AC are both 4 units. So this will be an isosceles right angle triangle. So this is also a isosceles CEL right angle triangle. And finally, example 3. Point ABC are the 3 vertex of a triangle. Prove that triangle ABC is a right angle triangle, and hence find the area. Well, actually, this is quite similar to example 2. And therefore, again, we have to draw the diagram by ourselves first. But we can see that for point ABC, they have all positive y coordinates, 4, 2, 0. And the x coordinates are 1, negative 3, and plus 3. So we can draw it in this way. We have the x-axis right here, and the y-axis can be in the middle, because the x coordinates are start from negative 3 to plus 3. And we can simply omit the negative y-axis, because all the coordinates, y coordinates, are positive or 0. So point A, it will be 1, 4. Point B, minus 3 plus 2. And for point C, we have 3, 0. 3, 0. So this is our triangle ABC. And now we have to prove that triangle ABC is a right angle triangle. And probably angle A will be the right angle. But this is not necessarily true, because this diagram is not drawn to scale. So how can we prove that it is a right angle? And we can make use of the, remember in Form 2, the converse of Pythagoras theorem. We have to first find the length of all the sides of the triangle ABC, and then we add up the square of the 2 smaller sides and see the sum, whether the sum is equal to the length, the square of the longer side. So we have to find A, B, and A, C, and finally B, C. Therefore AB, AC, and BC. And for AB, we can start with point A, that's 1, 4. And then for point B, we have negative 3, minus negative 3, we have plus 3, and then minus 2. And for AC, again, we start with 1, 4. And for point C, we have 3, 0, minus 3, minus 0. For point B, we have minus 3, negative 2. And then for point C, we have 3, 0, minus 3, minus 0. And we can check this. This should be root 20. And again, for AC, we have as a square of 2, we have 4 plus 16. Again, root 20. For BC, we have the square of 6, we have 36 plus 4, we have root 40. And so it is quite obvious that the square of AB plus the square of AC, these are the two shorter sides. and the sum will equal to the square of BC. So we can write this in this way: square of AB plus square of AC. We just find this expression, the value of this expression. And it happens that this equals to the square of BC. Therefore, triangle ABC is right angled. And but actually we can do more than this. AB also equals to AC, so it is also an isosceles triangle. And we can do something more, do something extra. AB equals to AC. Therefore, triangle ABC is isosceles.